All right. Good morning, everyone. So we are now today going to take a break from promises. We're going to take a break from JavaScript, and we're going to be learning CSS. Which, if the verbal analytic part of your brain is overwhelmed, that's great because today is mostly visual. So let's talk about boxing. Not this kind of boxing. Also not, it doesn't work. Not this kind of boxing, but rather this kind of boxing. So I'm talking about the CSS box model, which is the description of how CSS lays out everything on the page. So box diagramming is a way of taking like a mock-up that a designer might give you and figuring out what are all the pieces of it that should eventually be translated into HTML elements, and how are you going to specify the layout of those elements in CSS. Okay, so a common workflow is that a designer gives you a they give you a mock-up. It might be just wireframes. More likely, it's like a full comp. And then you'll have to take this and figure out how to turn it into eventually HTML, and then how to lay that out. So you can, so drawing a box diagram of the page, especially at first when you're learning CSS, can help facilitate this iterative process of building something, and possibly going back to the client and being like, here's what we made, this and this is hard to do or doesn't work, and it might be better, especially for mobile or for a big screen, to do this other thing. So let's talk about how CSS, or the general model of how CSS is going to draw our pages. So we don't get to write a layout function that recursively traverses the DOM and figures out the position of all the boxes, which is actually unfortunate because we would probably do a better job. Well, we might do a better job. We would have the power to do a better job. We would also have the power to do a much worse job, which probably most sites would. But I would do a better job, so I'm sad. But even though we don't get to write this function does exist somewhere within the web browser. It's not in JavaScript. It's written in C++. But it will recursively traverse the DOM and figure out the position of, the size and position of each node on the page, of each element. And it does that based on the size and position of the ancestors and children of a node, and also the styles applied to that node. So if we have a parent node and a bunch of children, we might end up getting these boxes for them. So by default, the children are going to flow top to bottom if they're block positioned, and then the parent is going to contain all of them. Just kind of what you would expect. Okay, so what is the shape of our CSS universe? So this is true of not just CSS, but web pages in general, and in fact, most apps work this way. The coordinate system for most computer graphics things is this way, where we have, why is that not? Oh, maybe there's a gutter on the side of the page? Yeah, there's a gutter. So the origin, the Cartesian origin, 0, 0, is the upper left-hand side of the page. The story is that this is because in old computer monitors were scantrons, or were CRTs, so there was an electron gun scanning from the upper left across and then scanning all the rows down. And so 0, its 0 point, is literally the top left of the screen. I'm actually not even sure I totally believe this. It also kind of makes sense if you're laying out text or text-like things in a top-to-bottom, left-to-right writing system to position the origin as being the upper left of the screen. Almost all computer graphics are this way, with the exception of window positions in macOS. In macOS, or like in Cocoa, the lower left-hand side is the origin, which is kind of what you would expect mathematically, but is confusing as hell for coming from any other system. So that's the origin, and then the origin of the page does not change, but rather the entire coordinate system translates when you scroll. So when we're scrolling, all of the positions of the elements remain the same because they're positioned relative to the page's coordinate system, but then the entire page changes, or the entire page's offset changes. The terms for this are like this: the thing behind the screen is the page, and then the window itself is called the viewport. So sometimes you'll see that like, doesn't this positioning model affixes a box to the viewport? That means that it's taken out of the page, which scrolls and is instead stuck to the glass of the screen. Not literally, obviously, but it behaves that way. Okay, so how big is this box? Nobody knows. It depends on what's in it. And that's the default in CSS, is that boxes are sized based on their content. So we have various ways of measuring things when we want to explicitly specify the size of something. We can give percentages relative to something else. So if I just say 50%, that usually means 50% of my parent container. If I say what rems are, ems are relative to the current font size. Rems are probably also relative to the current font size in some way that I don't know. Someone should look that up and tell me. Or we can provide absolute sizes, which again are not actually precisely absolute. 50 pixels means 50 CSS pixels, which have a tenuous at best relationship to actual pixels on your screen. 10 points is, we're measuring in points, which are, I think it's 12 pixels per point. They're meant to be a typographic measurement, but in CSS they have like an exact multiplier to pixels. And inches, centimeters, and millimeters are also exact multipliers of pixels. They don't have to do with the dot pitch of your screen, which is basically because people coded sites that used these measurements, but they didn't mean it. What they meant was like about 90 pixels, which was about what it was on their screen. And so at some point, when screens started to get high DPI, we had to decide what to do about these measurements. Like, does a CSS pixel actually literally mean 1 pixel, and we trust that all websites have written their styles in a sort of device-independent way? No, nobody had done that. Everyone was like using some mishmash of pixels and inches and expecting them to work out, so CSS adopted what was actually happening in the wild. Which is why we now have this notion of CSS pixels, which are on, if you have a Retina display, they will be like 2 actual pixels. Or if you have a Retina display and you're zoomed, you've like pinch zoomed, there'll be some other higher multiplier of it, because that's how the zooming works. Yeah, this is just a mess. Oh well. People are actually using it, so of course it's going to be a mess. Yeah, so EM, 1M is supposedly the height of a lowercase letter m. Maybe an uppercase letter m.
I just looked up the difference. It says m is relative to the font size of its direct parent, and rem is relative to the root font size.
Oh, root. Okay. That makes sense. So the font size on like the HTML element.
Yeah.
Okay.
Google says.
Okay. I don't use those measurements, actually. In fact, because almost all of these are based on, like, all of these boil down to pixels almost, I usually just use pixels to present.
It seemed like the rem and m were used primarily
For set font sizes.
for IE. Scales.
Does it, though?
So Internet Explorer wouldn't let you change the font size as easily as other
So it was
It was
right,
2.2,
right.
and then
Yeah.
with rem, you could describe the font size in HTML, or set that, and then change it throughout the page by saying,
Yeah.
according to this root of this many pixels, do this percentage of that.
Right. So this is not a. Oh, right. So REM is a percent of the root font size. Okay, cool. There's some other absolute units that are useful, or no, I guess they're relative units. Sorry. VW is percent of the viewport width. VH is percent of the viewport height. Those can be really nice if you're like, I want something halfway over the screen. It's 50 VW. You know that now. And then there's fracts, which are fractional parts of your containing element, which are a new unit introduced for CSS grids that I encourage you to look at because it's a really cool CSS module, but the adoption isn't quite there yet to be used in like production sites. But give it a year. Okay, so let's talk about the box model. How do we put stuff on the screen? So in CSS, every element that gets a box, so like every element that is drawn on screen, has these parts. Like every box has these parts. The inner part is the content, and that is the actual stuff. It is like, if I have a heading, which I wish this was as an example, that would be the like actual text. And then around the content is padding. It's another box. Around the padding is the border, which is usually filled with the border color. And then around the border is the margin. So if we can tell CSS how we want to, like, basically which one of these boxes we want to specify the size of. So by default, we're specifying the size of the content box. If I say like something is width 20 pixels, I'm saying the content of this will be 20 pixels, and then padding, border, and margin add to that. If I say that it's padding box, then I'm specifying the size of the padding box. And if I'm saying border box, then I'm specifying the size of the border box, so to the outside of the border, which is, if you're trying to get things to like fit together neatly and they have borders on them, this one is usually what makes the most sense, because if you have two boxes and you specify their width to be 20 pixels each, then you will, and they have no margin, then they will end up directly abutting each other, and their borders will be touching, and the whole thing will be 40 pixels, which is usually the behavior you want.
So it seems like the height and the width are like the height and the width according to the entire screen. There's a way to set it, let's say the border between the margin and the padding?
No, so the height and the width of, wait, of what thing?
You normally set the size of the border based on like pixels.
Yeah, so
You
if,
use height and width to define
no,
the border.
yeah, sorry, but if you, but you use height and width to specify the size of one of these boxes. Like when I say, oh god, when I say width 20 pixels, height 10 pixels, say, then I'm specifying the height of either the content box by default, or the padding box, or the border box. And then the sizes of the other boxes are computed relative to that. So if I say that, if I have like box size and content box, which is the default, and width 20, height 10, then my padding will add to that. So if I say padding 5 pixels, then the padding box will be width 25, height 20, width 15, height 25. And then if I say border 1 pixel, it'll be the size of the border box will be one more on top of that. So width 16, height 26.
And is there a specification for thickness of each one, or that's also relative?
That is what you're specifying is the thickness. So border width is the thickness of the border box. And you can do like border, wait, is it border width? No, it's just border top, border. Yeah, I always use the long form rather, or I always use the shorthand properties. I don't remember all the names of the sub properties. But yeah, you specify the size of of like the padding, border, and margin boxes on the top left, bottom, and right. Which maybe we're about to see an example. Oh yeah, and then the background is painted over the padding. And then the border is painted over the border, and there's nothing painted on the margin. Margins also have this special behavior where they, vertical margins collapse into each other. So basically the vertical margins of boxes are allowed to overlap. Okay, so by default, the parent height is the sum of the children's height, and similarly its width is the largest of the children's width. This is for a parent that is flowing its children normally. You can also tell parents to flow their children like using flex rules, which give you more control, actually, and are generally preferable, or using grid rules, which give you crazy amounts of control at the cost of being more complicated. But with the default rules, if I have these 5 boxes in a parent, it'll be the sum of their heights. If I lose one for whatever reason, then the parent will shrink to fit.
Is that the height of the whole thing with borders and
Mm-hmm.
margins?
Yeah, and assuming this is the height of the whole children, margins and all. Okay, and so this model applies to everything on the screen recursively. So the parent has margin, border, padding, and content, which contains more boxes, each of which have margin, border, padding, and content, all the way down. It's just turtles all the way down until you get to text, and then it's not turtles anymore. It's this other thing. Text layout is hard. I encourage you to write a text layout algorithm sometime. You'll learn true suffering. Okay, so this is sort of the default way that what are called block positioned elements are positioned. There are many other positioning modes. Let's look at a couple of them. So not narcissistic personality disorder. Browser. Here we go. Okay, so the default positioning mode is static. So that's what I was just describing. With static positioning, any element that is positioned static is not positioned specially. It fits into its parent like those children were fitting into their parent, just like one stacked on top of another. Relative positioning positions you relative to your closest positioned ancestor, meaning typically you have a parent box that has position relative, and then a child box that also has position relative. By default, this puts you in the same position as you would have gotten with static, but then you can change it. So I can say, put me where I would have been, but move me 20 left, or 20 higher, and then 20 to the left. And in this case, we're giving ourselves a particular width, although we didn't have to do that. Yeah. Oh, yeah. Don't pay attention to me. So fixed elements are taken out of the normal flow. So basically, as far as the parent is concerned, they do not exist. This is different from relative elements, where as far as the parent is concerned, they do still exist, and in fact, they exist where they were, which means there is a hole where they were. Fixed elements are taken out of the flow, and they're affixed to the viewport. So this is the fixed element that is like at this point in the page. It does not leave a gap where it would have been. And this is still true. Mobile browsers still kind of suck at this for all variety of reasons. It's gotten better, but it's it's still just really surprisingly bad.
Is that like the one where if you scroll but your like thing would stay? Is that
Yeah. So that's a great use of fixed position. There's also, I wonder if it's here, sticky. No. So yeah, we'll look at it. There's a couple of other positioning modes like sticky that are useful for like. We'll just look at an example. It's totally clear what it's useful for when you see that. Absolute positioning it's tricky, but it's also like really useful. So when you absolutely position an element, it is positioned, again, not relative to its parent, but relative to its nearest positioned ancestor. So the nearest ancestor that has position either relative, absolute, or fixed. And you can specify the position in terms of top right with, or top right, bottom, or left. And you don't have to provide all of them. So in this case, we're saying right 0, and that bumps the right-hand side of this element over to the right-hand side if it's positioned to ancestor. We don't have to specify the left coordinate, which actually means we don't need to know the width of the thing. So this is really useful for like putting a little tag inside of another box. So it's like, I want something that's on the lower right-hand side of this box always. Position absolute is a good way to do that. The caveat here is that these are taken out of the normal flow, and so things don't like flow around them. So if you stick something with position absolute in like the lower right-hand side of the box, it'll overlap or underlap anything that's behind it, but the browser won't like flow text to avoid it. Is this something I want to see? No, I don't care about this. Let's look at one more thing. MBN position sticky. Sticky positioning. Oh, here we go. Okay, so in this example, the headers have been positioned sticky. I could describe how, like, the formal definition, which it's that it scrolls with the element content until the top edge of the element is outside of the viewport, and then it's position fixed until the element is not in the viewport. But I think that's more confusing than being like, it does that thing. So if you want that thing, position sticky is what you want. There's some caveats about like, you have to set up the ancestry of these things correctly. So like actually maybe it's not that bad. Maybe you just need to say that it's position sticky, and then there's ways you can make it not work. So I would read this section if you find yourself interested in using it, but know that that is a CSS option. The last thing that's very useful, although less so for this part of the workshop and more so for the part this afternoon, is Flexbox. This remains I think this one remains my go-to. Yeah, this remains my go-to, like how to do Flexbox. Basically, Flexbox gives you all these properties for saying like, okay, I have a parent and it's got some children in it, and I want the children to flow within the parent in kind of a reasonable way. For various reasonable ways. Like either I want the children to be distributed with even space around them. I want their centers to be spaced evenly. I want them to fill the entire box. Maybe I want them to wrap into rows, or maybe I don't want them to wrap so that the whole element scrolls. And maybe I want it to flow left to right, or maybe I want them to flow top to bottom, because I'm laying out this thing on the side and I want my list of things to flow top to bottom. So most of the things you do with flex swaps, you could have done with something else, with much more work and in a jankier way. So this is particularly useful for responsive layouts that sort of make everything fit even at various screen sizes. So know that this exists. Know that this is a decent page for it. I'm sure there's other good guides. And as with all CSS things, I feel like ultimately just playing around with it is the way you learn. It's the way I learned it anyway. Okay, any questions? So the workshop this morning is rather like, what was that workshop that I didn't like very much? Schema design. Actually, I liked it with your cohort. I'm not sure why. We were going to get a layout and then come up with a box model for it. And the layout is in the workshop. It is for Casper. And it is a reasonably intricate layout that should be fun to diagram. So I will open that and make groups. Go ahead and take a little break. And we'll come back. You'll have like a little bit more time because I finished this lecture early. Yay.